Hello, welcome to Fagor CNC 8055 MC Profile Editor, lesson number 8, Troubleshooting Profile Editor, Profile Cutting, and Pocket Cutting. In lesson number 8, I will be using my simulator software, and you'll be using your 8055 MC front panel with your Enter key, Recall, Escape, up and down arrow keys, F3 to launch a profile cycle, and F5 to launch a pocket cutting cycle. Our first troubleshooting example is error in profile data. Let's start by pressing the F3 key. I'm going to go to profile number 23. I'm going to hit Recall. You'll find Recall on your front panel labeled Recall. I open up a blank screen in my profile editor, and I'm going to show you an example. Our first example, I've created a 90-degree arc, and the center is at x0, y minus 2, and the end point is 2.006, but the radius is 2 inches. So you can see that already this is a bit of a conflict. And anytime a line changes to the color blue, it means that it's incomplete and cannot be solved. Let's reproduce this in the profile editor, and let's look at some solutions. Okay, my initial starting point will be 0, 0. I will validate. I'll do a clockwise arc, x of 2.006, y2 to minus 2, x center of 0, y center of minus 2, and a radius of 2. So here we've completely reproduced it. The line is in blue, which means it cannot be solved given the data that we've entered. If I try to validate it, I get a box that pops up that says error in profile data. Press Enter or Escape. If I press Escape, the step remains incompleted, and I must edit it to reach a solution with the validate. So if I come down and I remove the radius value, you can see that there's still no solution. Put the radius value back in. Okay. If I remove the x center value as a fixed value and allow it to become a floating value, there, it turned purple. So this is one solution, is to allow one of the values to become a floating value. So the control will recalculate the x center to allow the arc to retangent between the 2 points by moving the x center over. But let's say the center, I'm fixed on that it must be 0. Okay, then I must become flexible on this endpoint. If I change that to 2.005, that does give me a solution. So, but you can see that the endpoint is 5 thousandths off. So the profile editor is allowing me to describe this with an endpoint that's 5 thousandths off and still provide a solution. But if I go back to 6 thousandths, again, it's unsolvable at this state. So if I'm fixed where I must have this value, then I must make the center a blank value so that it's floating. And also I could leave the radius value off and allow that to be a floating value, where the profile editor will solve both this value and this value. Let's go ahead and validate it and see what it looks like. Here you can see that it solved it, but it thinks that the center should be at 0.00599 and the radius should be 2.00001. So this is a solution when the math is in conflict with the profile editor. A lot of times you're working from a blueprint and you're working from a 3-place decimal, and those values are rounded. And sometimes when entering rounded values, you'll run into a conflict. The profile editor in the Fagor can go up to a 5-place decimal. So you'll have to expect that sometimes you'll have to leave one or more values floating, which means that they're adjustable by the profile editor during the validate. Let's now look at a second example of error in profile data. Here we have another example where we have an arc that's 180 degrees. The X starting point is at 0. The Y starting point is at minus 4.005. The X center is at 0, the Y center is at minus 2, and the radius is 2. And in this scenario, it's unsolvable because the endpoint is off 5 thousandths in the minus direction. Let's reproduce this in the profile editor and look for a solution. Edit, Profile, Initial point, 0, Clockwise arc, X is 0, Y is minus 4.005, X center is at 0, Y center is at minus 2, and radius of 2. So you can see that, again, this is in blue, which means it cannot be solved in its present state. If I press validate, again, I get error in profile data, escape. So one of these values will have to be adjusted or eliminated so that the profile editor can solve it and put the adjusted value in. If I were to adjust this point to minus 4.004, enter, it turns purple, which means it's now solvable. So simply moving the endpoint in a more favorable direction by 1 thousandths allowed us a solution here. But if I was sticking to this value and I'm not flexible on it, I could eliminate the Y center, and that allows the center to float, but the radius value really should also be eliminated to allow that to be a floating value as well, because it's not possible, given this endpoint, to have a 2-inch radius. So if I leave the Y center and the radius as a floating value and let the control solve it, if I validate it, here the Y center has been recalculated to minus 2.0025 and the radius, same value. So that presents us with a solution. Again, I'll either have to adjust this or leave these values blank and let the control solve those as floating values. Let's now look at a third example of error in profile data. Here I have an arc that's 270 degrees, and the X start is at minus 2.005. The Y2 is at minus 2 inches, the X center is at 0, the Y center is at minus 2, and the radius is 2. Let's reconstruct this in the profile editor and find a solution. There's my initial point, clockwise arc, to X minus 2.005, Y2 minus 2, X center 0, Y center minus 2, radius of 2. Okay, again, if I try to validate, I get error in profile data. It's not solvable using all of these values. If I were to try to adjust this value to minus 2.004, with a new value of minus 2.004, it now turns purple, which means it's solvable using this center data and the radius. If I was not flexible on this number and I wanted it to be fixed, I could blank out the center value and now it is solvable. If I blank out the radius and I were to validate this, you can see that the radius was slightly adjusted and the x-center was adjusted to minus 0.00499. So this does present a solution to us. If, however, the center are to be fixed values and the radius to be a fixed value, then I have to make a decision to either move the x2 endpoint or the y2 endpoint. Another possibility is that I could blank out the x2 and let the control completely solve it. So in this case, I've blanked out the x2 and it's still in blue, but unlike the previous attempts, when I press the validate, it'll turn to a green line and it's now giving me choices. It has possible solutions for me, more than one. If it only had one solution, it would have just turned to the color white. If I press next, there's one solution. Next, here's another solution. And that's because the x2 value has been blanked out and it's a floating value, so it could be here as a positive 2 inches or over here as a negative 2 inches. So again, if I press next and I press enter for this choice, you'll see that x2 was recalculated to minus 2 inches even. So this is a solution when presented with the problem of error in profile data. Let's look at a final example of incomplete profile data. Here I have an arc that's greater than 270 degrees. Its endpoint is at minus 0.0003, 3/10,000ths of an inch, and therefore it's not a full 360 degree circle, it's just shy of that. So it's greater than 270 but less than 360. Here we have a y2 of 0, the x-center of 0, the y-center of minus 2, and the radius of 2. Let's reproduce this in the profile editor and look for a solution. Clockwise arc, x minus 0003, y2 of 0, x-center of 0, y-center minus 2, and a radius of 2. And you can see that it's already in purple, which means that it's solvable in this state. And when we looked at the example, it was also in purple. But what this example is really to show you is, what if I change this value to 4/10,000ths of an inch? It disappeared on me. Now I have no solution. And I also now get no preview because the distance between the beginning point and the end point are so small that there's no way to show a preview. So here, just being off 4/10,000ths of an inch, 0.0004 on the end point, I'm stuck with a situation where I have no preview in blue, and I'm left to solve this. There we go. Now I'm only off 2/10,000ths of an inch in the minus direction. Of course, solutions for this are not needed because the line is already in purple, which means it's solvable in this state. Let's take a look at what happens if I cross beyond center to 0.0001. Here, I'm only 1/10,000th of an inch beyond center, but when I save this, no solution. What if I come down and I leave the y-center as a floating value? Does that present a solution? No. What if I leave the radius as a floating value? Does that present a solution? No, it does not. So sometimes you will come right up against a brick wall when you have so little distance between your origin point and your ending point that there is no solution possible, even if you leave the values as floating values. Of course, if I leave this as a blank value, that instantly presents a solution. But let's take a look and see just how far off I'd have to be to have no solution. Again, 1/10,000th of an inch beyond center, and that's a very small distance to be off. About 5/100,000ths of an inch. Still no solution. About 1/100,000th of an inch. Still no solution. So this one is really tricky, because here we have a full 5-place decimal and we're only off 1 digit on the 5th place decimal, and we still have no solution, and leaving the y-center blank and the radius blank still leaves us with no solution. So under these circumstances, when you run up against this issue, you will have no choice but to leave the x2 or the y2 as a floating value. So simply leaving it blank, allowing the control to solve it, and there it's recalculated it, given the information from the x-center and the radius, and the x2 is now 0. So this is an example to show you that you could be off as little as just 1/100,000th of an inch and still have no solution. You're going to have to blank out one of the endpoints and let the control profile editor solve it to adjust the value to be synchronized with the profile editor. This now completes the discussion on error in profile data. If when you're creating profiles you find yourself with an error in profile data, again, you'll have to become flexible on your endpoints by either allowing the control to solve them or leaving some values blank for either one value for the center or the radius, and let the control solve those values if it can find a solution. In our next troubleshooting example, we'll talk about an error called step in path. And step in path is exclusive to the F3 profile cycle. Let's begin there. We're going to go to our profile number. I've already drawn an example. I'll press recall. Here we have an example of a line beginning at x1, y-1, traveling to x2, x2.1, y-1.1, x2.2, y-1, and finally to x of 4, y-1. And the problem that we're going to see here is that I have a 2-inch cutter. And the 2-inch cutter cannot get down into this small step. So literally the cutter is going to travel over the top of it. But because we have this small step in path, we're going to get an error, basically telling us that the cutter with compensation cannot get in tangent to this line or this line. Let's take a look at this by finishing. Let's go to the graphics simulator. Clear the screen, cycle start, and there we have it. CNC 1068 error, step in straight path. And it's exactly what it is. We have a step in our straight path, and the tool cannot tangent to those steps. And in the conversational, we basically have a 1 or 2 block look ahead, and what we saw was 3 blocks look ahead required to go beyond that step. So this presents an error to us. So let's go back to our profile again and see if there is a solution present in the profile editor. One possible solution is to reduce your tool size so that it can physically tangent to this line or this line, which would eliminate the error. of step and straight path. So simply by reducing the tool size from a 1/2 inch down to 1/8 of an inch would solve this. Let's take a look and see if that is a solution. So here, reducing our tool size down to only 1/8 inch diameter provided a solution for us, because the tool was now allowed to go down into this feature, this step, and it was allowed to tangent physically to this surface and this surface. So basically it was allowed to touch every line in the path. Another tool that I like to use when diagnosing a step and path error is the cutter comp control. Here we have the icon for left cutter comp. If I change the 1/2 key, I can change that to center path of tool, which means there is no cutter comp. I'll again go to the graphics icon key, and I'll run this project with the 1/2 inch tool diameter that I previously had. And you can see that it runs center path of tool just fine without the error. So when you're presented with the step in path error, it'll run up to the step in path, it'll flag the error, and it won't complete the project, sometimes not allowing you to diagnose it. So by going back to the profile, turning this to center path, going back to graphics, and running this will allow you to run it without the step in path error. And this is where you can see where the step and path exists and what your options are, whether you're going to reduce the tool size or you're going to have to increase the length or width of these steps to allow the tool to reach tangency inside the step. At this point, I'd like to make a special note about programming and step and path. I'm going to go to the part program on your front panel. It's the key labeled P.program. This is your part program library. Here we're on program number 8, step and path, and when saving profiling, this is what it would look like in your program. What I've done is I've created a special step and path program over here, and this one's written in G-code language. And down here we have a special command in G-code that's not available in conversational, G41N2. And what this is telling the control is that I'm going to activate G41 left side cutter comp, but I'm going to do a 2-block look ahead for collision control. So if I try to run this program in the graphics editor with a 1/2 inch tool diameter, even the G-code program gives me a CNC 1068 step and straight path. And here it tells me specifically the line where the step is that it has a problem with. The G-code has one enhancement over the conversational. If I come to this line and I make a change to N2, make that N3, and replace it. N3 now gives me 3-block look ahead. Let's run this now in the graphics simulator with 3-block look ahead. Here the project completed itself, and it skipped the small step by shooting right past it because I've given it a 3-block look ahead. So it looked in the tool path, saw that it cannot physically go down inside the small step, so it went over it. And that's called collision detection. And that's a feature available in the G-code side. The conversational side is restricted to 1 and 2 block look ahead. With G-code collision detection, you can specify in your program up to 50 blocks in advance to monitor in your toolpath. A recap on step and path in the conversational profiling, the only two solutions available are either to modify the profile so that the steps are larger where the tool can tangent to them, or reduce your tool size. Once you activate tool compensation left or right, you will only have a 1 or 2 block look ahead, and your tool path must not have any small steps that the tool cannot tangent to that are below 2 block look ahead. Let's now look at another example. Let's go to F3, and this time it's related to your X and your Y starting point. Let's take a look at a part that I previously drawn in the profile editor. Here it's very simple. It just has a starting point and a line with an ending point. There is no step in path. But when I go to the graphics icon key, clear the screen, cycle start, I get 1068 step in straight path. And it's right here at the beginning of the profile. So if I go in here, you can see that there's physically nothing wrong with the profile. The problem is that I've plotted a starting point right here at x 1.1, y minus 0.9. So physically, I'm right here. So I'm only 100 thousandths away. This small movement here is not enough to activate the tool radius compensation, therefore presents us with a small step in path. So the small step in path was created artificially by our start point. So here I would have to modify my start point. If I start at x 0.5, y minus 0.5, then I go to the graphics icon key, clear the screen, cycle start. You can see that works perfectly fine. Now we wrap it to this point. We activate cutter comp from this point to our beginning here, and this line is long enough that it's not a small step in our path, and we successfully activated our cutter comp to machine across the part. So again, that's our solution here. And another way to view this, again, is to come here, change this to no cutter compensation, go to graphics, new screen, cycle start, and here you can clearly see it, that is our small step in path that's presenting the error to us. Changing that to left side cutter comp, saving it, and going back to graphics, clear screen, cycle start. Again, we have step in straight path. So again, once you activate the cutter compensation, you must correct your starting point to make sure you have enough room to activate your cutter compensation before arriving to your profile beginning point. This concludes our discussion on step and path. Our next troubleshooting item that we'd like to cover is a nested corner start end. And this is an item that is exclusive to F3 profiling. If we go to our profile, here I have created a simple triangle. A triangle origin starts here, goes counterclockwise back to the origin. Okay. I need to modify my start point to x of 0, y minus 0.5. So I'm clearly inside the triangle. Left side tool comp activated. If I go to the graphics icon key, clear the screen, start, display, optimize, you can see that we have a problem here. If I escape and I turn off the left side tool comp to center path of tool, save that, back to graphics, So here is the uncompensated toolpath, and the green represents the compensated toolpath. But you can see that we have overshot, and we're actually going to dig in and gouge this beginning ending point with our tool. And the problem is that profiles don't have to be closed shapes. They can be open-ended shapes. So once you activate cutter comp, it's only tangent to the first surface. And if you remember from our previous discussion we had about step and path, the cutter comp look ahead in conversational is only 1 or 2 blocks. So we have 1 block, 2 blocks. This is our 3rd block. So the control cannot see the 3rd path. It can only see the 1st and the 2nd. So what's going to happen is we're going to come over here, we're going to activate our tool comp to here, but we're only tangent to this surface. We're not tangent to the exit surface. So this is where we're going to get our gouge. Let's escape out of here. Let's now take a look at the exact same example using the F5 key, which is Profile Pocket 2D. And here I already have an example already created in the profile editor. It's the exact same triangle, but this time instead of profiling it, we're going to cut this as a pocket. So if I go to the graphics icon key, clear it, cycle start, you can see that it starts in the center, clears the pocket out, but when it comes time for the finish pass, you're going to see that we have this nice lead on and lead off feature that was automatically added as part of the pocket cycle. So the pocket cycle has some advanced algorithms that not only moved the starting point from here, but moved it down further onto the straight line so that it could actually do a lead on and a lead off radius based on your tool size. So you're not going to have the nested corner start and end feature as part of a pocket. It would only be as part of a profile. And again, because the CNC sees all pockets as closed shapes, but profiles can be open, there's many more considerations to take into effect. Let's quickly recap the nested corner start end, which is exclusive to the F3 profile key. Here I have a profile that's drawn, and I've started here. The tool is nested into this beginning ending point. You go to graphics, clear screen, cycle start. You can see that uncompensated, not a problem. It comes up to the starting point, goes around the profile, goes back. But once you activate the cutter compensation, left, go back to graphics, cycle start, you can see that we're going to gouge the part up here because we've started at a nested corner. Under these circumstances, your best solution is to start in the middle of a line and not in a nested corner. This concludes our discussion on nested corner start end. In our next troubleshooting example, we want to talk about an error that's exclusive to the pocket cycle only. If we go to F5, I've already pre-drawn a shape. Let's go to recall. Here I have a triangle that looks like our previous example. When I go to the graphics key, clear it, cycle start, I get an error, CNC 3860 plain profile open in irregular pocket. Let's take a look and see what the problem is. If I go to the modify key and modify an element, I can go to each element, next or previous, highlight it in red, and I can look at the information. I can see that this line starts at x0, y0, ends at x minus 2, y minus 3, the angle. Next. This one looks good. Next. If you remember from our previous examples that we talked about in the error in data, we talked about sometimes being off on the 5th place decimal just by 1/100,000th of an inch is enough to error out in the profile editor with incomplete profile data. Here, this is resulting in an error that says that this shape is not closed. When creating shapes in the profile editor for pocket cutting, they must all be completely closed, whether they're islands or they're pocket perimeters. They can't be open shapes like they can when profile cutting under the F3 key. When under the F5 key for pocket cutting, you must have all your shapes closed, which means that the beginning point and the ending points must be identical. Even being off 1/100,000th of an inch is enough to give you the error. So of course the solution is to edit this, edit a straight line, 0, 0, validate. I've now made the correction. Save and continue, exit twice, finish, save it. Now go back to graphics, clear screen, and now the cycle runs complete. Let's recap. Again, the beginning point and the ending point must be exactly the same numbers. There cannot be any difference between them, otherwise it will result in the error that the profile shape is not closed. The next troubleshooting example we'd like to talk about is the number of finish passes on the sidewall for Profile Pocket 2D. This is not a feature available in the profile cutting under the F3 key, but exclusive to the F5 key for Profile Pocket 2D. And the feature we're talking about is right here. When defining your finish pass, you define your tool number, your entry angle, the amount of material to be left on the sidewall and on the bottom of the pocket, and here you have to give it a number of how many depths of cuts on the sidewall here that you want to make for the finish pass. Up here you specify a depth and the increment depth for cut. But here, once the material's all been removed in roughing, how many sidewall passes do you want to take? Okay, you could take that in 1 or 2 or 3. Okay, and when you go to the graphics icon key, type of graphics, 3D, clear the screen, cycle start. You can see here that we had 3 depths of cut. Here, you can see it better. You can see that we have 3 depth of cuts on the finish pass. So the green line that represents the finish pass, there's 3 of them. Okay, and this time if we change this to 1 and run the graphics again, your screen, you can see that we only received 1 finish pass on the sidewall. So basically Z goes to depth and performs 1 finish pass on the sidewall. Okay. And here is an example if we have n equals 0. And under this condition, clear screen, cycle start, you'll see that the pocket was roughed out with 2 depths of cut, but there was no finish pass applied. So in this example, N0 does not work to our advantage unless we want to turn off the finish pass. Normally we would change the tool number to 0 if we wanted to eliminate either the rough pass or the finish pass, but here in this cycle, by changing N equals 0, it also eliminates the finish pass. So sometimes when you're running the cycle and you notice that there's no finish pass, you'll have to come here to make sure that N has at least a value of 1 for 1 depth of cut for a finish pass. This concludes lesson number 8, troubleshooting profile editor, profile cutting, and pocket cutting.